night, everyone. Today we are going along our journey of total surface area as part of our measurement content, and so we'll run through a few shapes, and hopefully this is becoming familiar, and it's just an extension of actually finding the area of a shape. So total surface area is pretty much finding the area of a composite shape, which some of us have already done. Okay, so if we look at the shapes to the left on the screen here, hopefully we can see that having 6 identical, not that it's marked, but it could be marked so that we know that each of those is identical. Okay, we can do that all the way around. So we've got 6 identical squares that make up a 3D shape, and hopefully we can, from previous knowledge, understand that that is going to make up a square. So here we're just recognizing what shapes these nets make up. So if we were to draw this, we get a shape like that, and put in the back corners, etc. Okay, so we've got a cube there, and that helps us to visualize the parts of a shape when they're not laid out in a net, but also that knowing if we have a shape like this, we can lay it out in a net, and that can make it easier for some of us to identify. This one here makes us a square-based pyramid. So when I draw a square-based pyramid, I find the easiest way to do it is to draw the square base in terms of a parallelogram, and then from the middle of that, go up, pick a point up here somewhere, put a dot, and join that dot to my 4 corners. And we generally end up with a pretty nice square-based pyramid. Okay, so that's what makes up those two. Let's move down from there to finding the total area of this flattened 3D rectangle. Alright, so what I want us to think about here is we've got a few different areas involved. So we've got the squares here and here, and then we've also got these rectangles. Now in a rectangular prism we can have either the 2 ends the same, and then these parts that make up the body will all be the same in this one. So we've got 4 pieces there and here. Some of them though will have 3 pairs, so and we'll see that in the next problem, where the top and bottom, left and right, and the front and back pieces are the pairs that are the same length. But this one just has 2, so we can work this out. I'll do it in 2 pieces. So I'm going to do the squares. So our squares times 2. Okay, so the area of a square is given by L squared, the length squared. So I know I've got 2 of those, so I've got 2 times L squared. I'm just going to put that in that. Makes it stand out. So my squares, and 2 times the length there. So the length of these squares is 2. 2 times 2 squared, which is 4. And 2 times 4, oops, I'll get that there, is equal to 8. Okay, so if let's give it a unit, for instance, let's make them centimeters, and so that will be 8 centimeters square. Okay. Then we've got the rectangular prisms over this side. So the rectangular prisms there's 4 of them, as you can see in the pink there. So the rectangular prisms is length by width. Okay. And we've got 4 of them, so I will multiply that by 4. So as we move down, we've got 4 times, our length is 2, our width is 5, 2 by 5, 2 by 5 is 10, and then 4 times 10 is 40. Okay. And then for the total surface area, we just want to add the squares TSA plus our rectangles TSA. So there we end up with 8 plus 40 and end up with 48, and if we use the measurement, the unit we were using earlier, 48 centimeters square for that one. Okay, so on to something a little bit harder again. We've got two problems here, so I'll try and split the screen up a little bit to make it a bit easier. Insert a little line there. Okay, we'll do that there. And alrighty, so this is an example where we've got a few different shapes involved in this, a few different sized rectangles. So we've got a right and a left. So if I highlight that, so those two, that one there. That yellow doesn't come up very well on a red background. Then we've got at the front and back, we've got another pair, and there. And last of all, we've got our top and our bottom. Okay, those there. All right, so I'm going to rub that out because it's getting super messy. And that one doesn't want to rub out. There we go. Okay, so that's what we're going to split them up into. We're going to split them up into a few different rectangles. So I'm going to call them rectangle LR for left and right, then rectangle TB for top and bottom, and then lastly rectangle front, same, rectangle front and back. So there are our four parts, sorry, our three pairs. So left and right, we know that the area of a rectangle is length by width. We've got two because we've got left and right, so we're going to multiply one of those areas by 2 to get the complete. So left and right, we can see that we've got a width and a height of 5 and 4. So 5 times 4. So then 5 times 4 is 20. 2 20s are 40. Okay, so if one side's 20, the other side is 20, together they're 40, and that's centimeters squared. Then our top and bottom. So our top and bottom, you can see our bottom here has a length of 6 and a width of 5. So again, we've got two of these. So that's 2 by 6 by 5. Start working that out. So that's 2 by 30. Now these brackets, I like putting in brackets because you can see that that's the dimensions of one side. If you didn't put these in brackets, it wouldn't matter at all. The multiplication works out exactly the same. So 2 by 30 is 60 centimeters squared. And then this last one, front and back. So you can see this front, we've got 6 again. And then we're looking for the height. Okay, that height there is the same as this height here, which is 4 centimeters squared. So we've got 6 by 4. We've got a front and a back, so we've got 2 of those. Then let's work through that. So that's 2 times 6 by 4 is 24, and that gives me 48. Okay. Now the rectangles total surface area is equal to 40 plus 60 plus 48. Okay. Now I know that 40 and 60 is 100, and 48 on top of that is 148. So the total surface area of that rectangle here, that one right there, is 148 centimetres squared. Now, this pyramid here, this asks us a little bit more. Okay, so let's run through that. For this one, we have to actually find the height of the triangles. Now, we know the height of the pyramid, but I used this example before where I said, okay, if a tree is, if it's grown out on an angle, the height of the tree is not necessarily the length of, say, the trunk, etc. Okay, so here we've got the height of the pyramid, but what we need is the height of the triangle. All right, so we need to find h first. Now we do that by using Pythagoras' theorem. We've got a right angled triangle here. We know one side here. We know this bit along the base here is going to be half of 6, so that's 3. So we use that 3, 4, and we can use Pythag to use the rest. Now, some of us might know it as a Pythagorean triple, where it's going to be, our answer is going to be 5, but we'll run through that anyway. So h is the hypotenuse, so that's the longest side. So c squared equals 3 squared plus 4 squared. So let's square those two values that we can there. So that's 9 plus 16. And that'll give me 25 when I add those two together. Now, we still have the squared above the c, and we want to get rid of that. So to get rid of squared there, we want to go square root is the opposite of squaring. And we then have c is equal to 5. Okay. Now that we've got the height, we've got 4 triangles there. So we've got our triangles is equal to 4 times the base by height divided by 2. So 4 times the base is 6 for those. 6 by 5 is the height. Divide that by 2. So 6 times 5 is 30. Divide that by 2 is 15. So each one of those triangles has a surface area, or an area of 15. 4 times 15 is 60. So we get 60 centimetres squared for that. The last piece of our puzzle is we have a square base. Okay, we know that squares are equal to the length squared. So the length of one of those squares is 6. 6 squared is 36. And that's centimetres squared as well. So the TSA of that is equal to 60 plus 36, and that gives us 96 centimetres squared. Alrighty, so that is how, hopefully that noise in the background isn't coming through too much, but I've got a couple of young boys home who are causing a whole heap of noise. Hopefully that's not too hard for us now. And that you can rewind, go back over some of the base concepts if this one here is too hard. Okay, but that's a little bit more advanced because we're using Pythag to get through that. All right. If you have any comments, throw them in the or questions, throw them in the comments below. Like the video, subscribe to the channel to keep up to date with what's going on, and hopefully that was all good. Cheers, gang. See you next time.